Hello everyone, good morning, good afternoon. On behalf of Web Solutions, I would like to welcome you to our webinar, Enterprise Integration Patterns and Solutions for Architects. My name is Mikhail Vladimirov. I am the Director of Curriculum Architecture at Web Solutions. Web Solutions has been providing a broad spectrum of training and classes for over 10 years to many clients. And in today's webinar, we will be talking about many aspects related to enterprise integration as well as solutions. And while we primarily target architects as the primary audience, other people might also benefit from this presentation. We've got a great deal to cover, and I will try to keep up the tempo. If you have any questions, you can put them in the questions panel that is part of your go-to meeting console. And we also will have a Q&A session at the end of the presentation. So the first topic that we would cover is reviewing some of the reasons why some people might say that SOA failed. We're talking about service-oriented architecture. Where and why? And is it really the case? One of the reasons was for failure of some of the SOA-related projects was that SOA is an architecture evolution, not a revolution. And many people put too high hopes on SOA to solve all the problems so that it would be one size fits all, silver bullet, and so on and so forth. So many projects failed because everyone wanted to jump that bandwagon and try to SOA-ize, so to speak, as there is a word of that type, everything within enterprise. And in many cases, SOA was understood by architects as just a bunch of SOAP web services, rather than rethinking the way enterprise functions. Also, there were some quite obvious challenges, like over-engineered solutions that existed at a certain point in time, like UDDI, Universal Discovery registries, as well as advanced WS-star specifications, where people were struggling the spec rather than delivering value for their businesses. And in many cases, it was a lack of technical leadership. People didn't have enough knowledge and expertise and basically experience dealing with SOA projects. So SOA is not a silver bullet, and not every aspect of your enterprise is a good candidate. Such systems as high performance and mission critical real-time systems are not very well suited to be under the SOA umbrella. Business-to-business interactions involving very complex transaction semantics are also not a good candidate for SOA. Other things like batch processing in data warehouses and wherever there is an existing tight coupling between system and businesses that is not really worthwhile or does not easily lend itself to effective transformation into an SOA system. And sometimes it just would be a good idea just to keep things as they are. Here's an example of what you might consider a success when you apply SRA principles right. This is a slide from a presentation made by eBay software engineers, and it just shows how they implemented some of the principles of SRA. So they exposed a bunch of their services which are well hidden behind the multiple layers for security reasons and otherwise, and they exposed the entry point, service entry points through the SOAP and through the REST API. Those were the entry points for clients to access the system, whether they use browser clients, some sort of HTTP clients, or any thick clients that run some applications connecting to the infrastructure. So everything, the whole infrastructure is fronted by a logical load balancer, which in turn does not very much and just redirects all the requests to the enterprise service bus, which sits between the entry point, facade, and services on the right. So ASB does message routing, transformation of messages, mediation, and some other added value for the message flow. And we will be talking about many of those aspects in this presentation. Dr. Mark Little is the CTO of JBoss, and he has produced very interesting presentations over a period of time. And he is a lead authority in SRA and related topics. And one of his slides in one of his presentations, he wanted to sum up and put everything in just one slide, all the components of modern SRA architecture. It's a pretty busy slide, but the point here is that it's quite a sophisticated system, and everything starts from the bottom, where you would have the actual foundation for your SRA, which currently employs modern technologies like virtualization. Probably he has missed cloud deployment infrastructure, so that would be a new kid on block. And on top of that, you would have a great deal of components that deliver SRA. I'm not going to go through all the aspects in this diagram, but it's important to see that there are big blocks of functionality that is grouped using some affinity principles. For example, the process management and orchestration is bundled into this block, which includes business BPL, business rules, human workflow. Certain things have already been deprecated. For example, registry, UDDI, it has already become obsolete, and major vendors dropped support for UDDI, and other lifecycle, SRA lifecycle governance systems came aboard. But what is important in this regard is that you need to have a repository of whether it's a service or whether it's a set of business rules, and so on and so forth. Let's touch on some pragmatic, digestible SRA recommendations. It's important to stay unswayed, not affected by marketing hype, buzzwords, and some fancy technology. For example, in practice, many WS star specifications are not fully interoperable, and sometimes they create more problems than solve problems. So it's important to start moving and adopt RESTful HTTP web services, REST API, and expose your services accordingly. And it's important to stay within simple solutions so that you don't over-engineer, and you observe the KISS, keep it simple approach. And you would also benefit from trying out and maybe adopting some of the existing ASB/SOAI solutions, service-oriented integration solutions. But before, I guess, we start delving into more detailed review of those topics, we just need to go back to the basics. So there are some time-tested rules that I guess the evolving systems just confirm the existence and the validity of those rules. So data is the king, that's rule number one, and data would outlive your applications, whatever it is. And finally, applications would outlive integrations. For your business, data is at the core. It's the information asset that really shapes your business, what you do. And of course, you need to provide the proper level of integration to expose data through a meaningful API to make it available for consumption. Let's quickly define a pattern. So I guess most of you know what a pattern is, a design pattern is, and sometimes it might help also to look at pattern as a behavioral pattern. For example, fight or flight is one of those patterns. So on this cartoon, you see that you've got a solution for each and every situation. So your behavior depends on the situation, whether it would be fight, to put on the boxer gloves, or to fly, to put on those sneakers and run away. We will quickly touch on several authoritative sources in different parts of enterprise integration and SOA. And one of the fundamental book accepted by many is that Executing SOA, a book published by a number of authors. That book was published by IBM, and it contains a great deal of useful information, which might be dated a little bit, but still, nevertheless, it sets the right backdrop. Let's take a look at one of the not so hypothetical, theoretical problem. That's a real deal. So you've got data which resides in multiple sources and you would like to integrate it. Normally it happens as a result of some mergers and acquisitions that happen all the time in the market. And at the same time, data replication or copying over is not the right solution for many reasons. Data replication has complexity, and sometimes it would require support from the vendors that you might have, like Oracle or IBM, for their DB2, for their products, like based on their database products, like Oracle or DB2. And while those solutions exist, they might be pretty expensive. You also need to provide support for SOA and non-SOA applications. So what is required is a unified virtual view of multiple sources of data that sit on premise in your data centers in your enterprise. So what is the solution? Data federation pattern. So data federation pattern allows you to do all of those things. It has, of course, some pros and some cons, but in essence, a DFS, data federation server or service, provides you a real-time synchronous data integration point. It would perform all the necessary data partitioning from concurrent users, and it would also act as the front end for standard relational databases APIs, as well as service-oriented interfaces, whether it's SOAP or REST APIs. It acts in dual capacity. On one hand, it acts as a service provider of those integrated information services, servicing the requests from the clients. And at the same time, it acts as a client or consumer of those data sources that sit on-premise in your enterprise. In addition to that, data federation server provides some additional quality of services such as data synchronization, transactional support. So it would act as a point for to face commit, and it would also handle access control, authentication, and authorization. And while this pattern has existed around for quite a long time, that pattern has been reinvented again with API management offerings that we will be covering as well. So again, nothing new under the sun. Many things are just retrofitted, repackaged old solutions. But that's one of the, I guess, patterns that is used widely in enterprise. This slide summarizes all the interactions. So the data federation server sits in the middle. So it acts as a client to databases, CRM systems, and what's not. And at the same time, data federation server provides services to the clients, whether it's a web service client, or browser, portal server, or legacy application, which is probably follows that client-server paradigm. Data federation server enforces execution of business processes so that it would maintain some state for the session in order to complete like order request and things like that. So it would maintain traditional interfaces to its client, whether it's SQL and others. On the other hand, it would also have that new brave interfaces supporting WSDL, SOAP, and service component architecture, and so on and so forth. So we saw the business value of that service as an integration point, but at the same time it comes at a price. That data federation server is a single point of failure, and when it's down, you're pretty much toast. Transaction support might be a big headache, since transactions require synchronous access, and transactions involve a great deal of resource consumption, and it consumes some memory, CPU, and that might become really a bottleneck on the federation server. high availability. It's not easily enforced because you depend as a client for so many back-end services which might have their own understanding of what high availability is. So you pretty much act as the front end to those ill-behaving services, which might have interruption of services and maybe some scheduled maintenance windows and things like that. So let's also mention another book written by Thomas Earle. Thomas Earle is an authority not only on SOA design patterns but also on cloud solutions, and this person has a very good understanding of technology, and he also has the capacity to explain many of difficult technical concepts in a very good, very understandable form. So it's something that whenever you see Thomas Earle as an author on a book, it's a hallmark of clean and very concise explanation of difficult technological problems. In this book, he set himself a primary goal of providing a catalog of master patterns for SOA and service orientation. And here's an excerpt, a fragment of his pattern inventory that he covers in detail. And all of those things, as you see, have very nice summary, which in a very concise way describe what a particular pattern is. Let's touch on some of the patterns. I guess let's start from the bottom, because it's more of a kind of a newer pattern, event-driven messaging. That pattern is based on having consumers set up as subscribers of a particular service, and they expose callbacks, methods or functions that can be called by the service in response to some events. A notification in the form of a message is sent on that callback, and consumer would have a handler for that particular event and would react appropriately. Decoupled contract is a service contract where the interface or the contract of the service is decoupled from its implementation. So, for example, you can have WSDL document which includes schema or a set of schemas. That would be the contract between the service and consumer. But implementation can vary. It can be implemented as a service using .NET platform or Java or Perl or whatever is suitable, whatever knowledge is available inside the organization. And canonical schema, it's when your information sets are created as per some common standards. So one example could be XSD schema files, and that schema would be enforced across the enterprise so that all interested clients would be created as per that canonical schema. I'm not going to spend more time on that, but I guess that slide just captures some of the more important SOA patterns. So that catalog is quite exhaustive and an interesting read. So let's maybe take a look at how things are done, how they implement some of those patterns. So we've got service consumers, which can be quite a big variety of devices connecting to and trying to take advantage of the services. So those services WSDL file, WSDL file, which in turn includes schema files, XSD files. So service consumers would be interacting with the services by using that contract, which is decoupled from implementation. Meaning that as long as you would construct your HTTP or HTTPS request according to that contract, then it would be on it and you would get the correct response back. And normally there is an ESB, Enterprise Service Bus, which sits in the middle, which helps you to mediate and dispatch requests to the appropriate service. So as you see, by creating that decoupled scenario, you can achieve a great deal of flexibility, because as long as you publish your WSDL file, your XSD file, it can be published to your clients, and you can develop your services independently from your clients. And when the big bang time happens, you would be assured that when your consumers start connecting, they wouldn't have any issues. Some people would recognize this pattern as that old interface definition language, that RPC decoupled contract. So you would have the core bar objects that would be compliant with the core bar stubs, and your service consumers would also implement IDL so that they would be able to build their RPC requests to backend services. And object request brokers, core bar based, would help you to deliver that functionality. Enterprise application integration patterns published, written and published by two authors back in 2003, Hope and Wolf. They identified and described 65 integration patterns, and they did a very good job organizing them in logical categories. Here's a snapshot of some of the patterns that are described in this book. Let's take a look at, for example, this processing pipe, which is constructed from different patterns. For example, hopefully you can see it clearly, that router, which routes messages based on, say, content or maybe on some other rules. It's just a pattern which you can put together with the translator, which might translate messages, transform them from one format to another, and translator comes from another catalog message transformation bucket, and then after a message has been translated, it would be sent to the target application. Monitoring of the flow would be ensured by plugging in a monitoring system, which can be plugged in using various techniques, like, for example, wiretap, and all those system management patterns are grouped into a system management catalog. So there are some additional patterns which are covered in detail in this book. Let's take a look at ESBs and service-oriented integration patterns. So what is an ESB? It's an enterprise service bus, which from the SOA perspective is viewed as an integration platform, and ESB as an important part of service-oriented infrastructure. In a nutshell, ESB acts as the bridge between the service consumer, which is interested in consuming some of the services provided by the service provider, and ESB acts as the bridge between the consumer and service provider, providing transparent connectivity between the two. ESB also adds some very important enterprise quality of services such as security, maybe request throttling, high availability, and many others, pretty much protecting the service provider from service consumers. Here is a list of some of the core functions that ESB carries out when it is established and set up a new enterprise. Message routing, whether it's rule-based or message content-based. Location transparency. Normally this is done in a way so that service consumer has no idea where the actual service provider is located, and normally for that purpose some logical endpoints are used, and ESB does the mapping between the logical mapping into the physical mapping. Transport protocol mediation, where message can arrive as part of TCP IP stream, and those messages can be transformed into a GMS request, or HTTP request would be built based on information sent. Connectivity and interoperability, whether it's asynchronous or asynchronous communication, peer-to-peer or publish-subscribe, and many others. And what is also important is the monitoring and management, as we have seen in one of the patterns that ESB natively supports. So you don't have to do a great deal of research and development to achieve that. It would be just a matter of plugging the appropriate module from the system management pattern catalog. Again, there is another slide from Dr. Mark Little, the CTO of JBoss. This slide integrates all the aspects related to service-oriented infrastructure. So ESB sits in the middle, and it acts as an integration point between a variety of common set of services, and enterprise service bus can also be integrated with the service orchestration aspect of SOI, where certain things can be carried out in an orchestrated fashion. So you would have an activity diagram which would allow you to start a process and proceed from start to end, carrying out the business function in a well-organized form. And consumers would benefit from composite and rich applications that ESB/SOI provide. Many ESB vendors, whether they are in open domain like open source projects or proprietary ones, they strive to implement most of those 65 enterprise application integration patterns that we quickly reviewed. For example, MuleSoft ESB has Eclipse-based ESB Studio, which allows you to integrate and build your solutions by dragging and dropping various data integration primitives on from the palette of integration patterns on the canvas, where the whole solution would be built in a logical form. And then you can click generate, and it would give you auto-generated form of your data flow. There is a question from Star here, if I can give examples of any popular data federation server products available in the market. JBoss data virtualization, I guess JBoss probably offers you some of the components that would allow you to build your federation data federation server. I guess WebSphere, IBM's application server-based solutions from IBM can also fill in that gap. You can build systems according to the data federation server pattern, which would be, I guess, more expensive than JBoss's solution. I guess there is just a set of components that you need to structure in order to build your solutions, but definitely ESB would be an important part of that solution. ESB some view as another incarnation of enterprise application integration, and there is no surprise that many of the EAI original solution providers, like for example IBM, WebSphere message broker that you can use as a backbone for your data federation server, or TIBCO, BusinessWorks, Sonic XQ, they now are positioned as the ESB, enterprise ESBs. Some people might argue that it's pretty much the same. For example, JBoss ESB positions itself as the next generation of EI solutions. JBoss ESB can be used for the data federation server pattern as well. Mostly, I guess the biggest differentiation factor would be that EI solutions use proprietary technologies, and they're more about hub and spoke architecture implementations. ESB is more oriented towards bus-based architecture, but all those things, they are not conclusive. So you might still say that ESB is pretty much a new way to call an EAI solution. Open source ESBs is quite, so that space is quite vibrant. We've got quite a few open source offerings in this space. I'm not going to go through that list. Probably you are already using some of those. It also might be a good idea to review what is offered by other ESBs. Mule is a very popular open source ESB. So there is a question if slides deck would be available. I believe a link would be sent to you with the recorded webinar, as well as with the PDF of the slides. API management is a popular integration pattern which has been maturing over the last several years, and it's a really interesting concept. we currently experience API proliferation in the world. Netflix makes its recommendation based on the history of previously watched movies. They use internal APIs. Amazon makes product recommendation based on your browser history so that they can do that cross-sale. Everything is bundled with their internal APIs. And it might be a good idea to expose your internal services through the public API. So it's not so much about SOization of your services or your capabilities as it is of structuring it and building it in a proper way. So API management is an integration solution that helps expose your internal APIs through the public external interfaces. And normally they include a mediation engine like a service gateway, which provides all the necessary quality of services like security, threat and trust protection, and API meta information so that people can use it as a registry to select the most appropriate API for their purposes. And API management helps you to build, execute, and monetize your interfaces. So let's take a look at what we might have. So we would like to engage clients by exposing APIs for each and every system. And as you see, they're quite fragmented. So there is no way to maybe consolidate those services. And those services are difficult to scale. We need to ask questions how the versioning is done, where clients would get meta information about services, and how do we ensure authentication and authorization on the access points. So the solution is presented in the form of the API management. So here's a slide of conceptual architecture which shows you how things are done using the API management approach. So you would have on-premise or in-cloud deployment of the gateway, API gateway, which would expose your services through the public interfaces. And your clients would be using any form of connectors to your proxy, and the predominant API is REST APIs. Proxy gateway acts to ensure many functions such as security, protocol mediation, and so on and so forth. And for the most part, that gateway is backed up by an ESB of some sort. And your on-premise services are safely protected, safeguarded by the facade offered by the API management. It's an interesting proposition, so it's probably another incarnation of SOA exposure of your internal assets. API management also enforces lifecycle management like publishing and versioning of APIs. It also maintains a registry for meta information. It promotes system integration and service orchestration. It also enforces SLA, service level agreement aspects of service integration, as well as generates analytics and all the necessary reporting information that you might need. So what are the driving forces for API management? Those are to grow your business, to reduce cost and innovate. So you can grow business by virtue of exposing your useful APIs to the public. And you can do it through a number of channels. You can do it through the cloud, maybe opening the mobility channel, building a mobile version of the API management. Reducing cost is achieved by offloading security and other quality of services to the entry point, which is the proxy or API gateway. And at this point in time, you can start building mashups of services, which allows your users to innovate, because you would expose APIs in a way that would be helpful to combine services and build mashup services. And it looks like there is some interesting statistics that shows that 50% of the cost of new application development will be integration. And 75% of Fortune 500 companies would have web API of some sort by year 2014. This is according to Gartner Technology. Let's take a look at some of the practical implementations of that partnership. Mashary is a company who claim to be the inventor of API management. They use Intel SOA Expressway, which acts as a service gateway for their API management offerings. There is a direct competition from IBM in the form of data power SOA appliances. So Mashary built the platform in the form of community API portal, which provides a catalog for the API, wiki articles, blogs, articles, forums to help people learn about the API and they use it efficiently. API management life cycles is provided transparently through the portal, Mashary portal, and API security is enforced by implementation of the API management. Here is a complete picture. So you've got consumers who are interested in consuming on-premise applications which have some useful services that consumers would like to use. Consumers interact with RESTful facade, which sits in front of the Intel-based service gateway. This is an appliance which can be deployed on-premise or in the cloud. And develop a community who actually work with to help consumers to leverage existing services. They work through the API management portal where they would find out about APIs in blog articles, in forums, in other forms of collaborative interaction for social media networks. And that's how things are done. So Service Gateway enforces all the nitty-gritty details of interaction, such as it prevents SQL script injections, it will do denial of service prevention, HTTP authentication, credential mediation, and the whole slew of those services. So this is embedded in Intel Expressway appliance, and this is done very efficiently. So you pretty much passing on the security concerns from backend systems to that appliance. It achieves high performance by embedding many of those things internally into the system. So Intel Expressway provides efficient, cost-effective enforcement of quality of services that are needed. Cloud services integration is also an important part of new integration patterns. You need to evaluate services that are offered by different cloud vendors. Currently, Amazon Web Services, Microsoft Azure, and Google App Engine offer you a variety of cloud services that can help you achieve integration, which would happen in the cloud, which probably have some ramifications for you. You need to take into considerations the security aspect and other things, but at the same time it's worthwhile to take a look at what you can achieve by moving some of the integration work out in the cloud. So I'm not going to go through all those services. They're quite elaborate, and you would notice that there are some gaps which are not actually exist. For example, Amazon offers caching services, and there is also development kit for Amazon Beanstalk. I guess it's just a matter of that people prefer some other solutions from other vendors. One thing probably would be worthwhile to look is to see if combination of different services, for example, storage and compute. So those two services act together to achieve processing of data stored in an object storage of some sort, whether it's S3 storage or whether it's blob store. So it can achieve a good synergy in this department. Here's an example of what, how you can integrate some of the services using Amazon Cloud, AWS. So a client using a browser can connect to your services by using HTTP, HTTPS, and you would build your services by combining some of the components available in AWS. So you would have to leverage their load balancing facilities and elastic IP addresses, which helps you to assign a public IP address to new services that you create. And at the back end, you can use the S3 storage, and elastic block storage would be attached to EC2 instance. Elastic block storage is transferable, so you can pass it on between different EC2 modules. You can also leverage the existing relational database services as well as the NoSQL solutions. Here's an example of what you can achieve with Google App Engine. It's a platform as a service which offers a great deal of functionality out of the box. Of course, you are limited on the platform as a service. You are limited to the execution sandbox. You cannot do very much in terms of interacting with underlying file system or launching multiple threads. But in many cases, system would handle multi-threading on your behalf transparently, and you will have a choice of different languages, whether Java, Python, Google experimental language called Go. Google recently added support for PHP, so it's quite interesting in this area. And you can take advantage of the big table-based App Engine data store, which has all the redundancies, high availability qualities that you would expect of Google. And it has all those services that you might want to use in your application, whether you would like to do mailing services, authenticate your clients, image processing, and instant messaging. Google App Engine also supports scheduling. So it supports a way to schedule some of the repeated tasks. So it's possible to configure a cron job through a configuration file, which would invoke a service at a specific point in time. So it's an interesting proposition. So if it's I guess it might be worthwhile to take a look. Our offerings, we offer a two-day class enterprise integration patterns, which covers all of those topics in detail, plus some hands-on practice using different technologies so that you can consolidate your knowledge and make sure that you have understood all the concepts right. So any questions? And we have about 5 minutes to take those. The question is, any thoughts, pros and cons, if you can share, to have a standalone ESB platform versus Camel, any Lightform, or WebSphere app server. So what I can say in this regard, I guess Apache Camel, it's a very lightweight thing. You would need, I guess, do some extra work, as opposed to maybe using MuleSoft ESB. So MuleSoft ESB functionally would be similar to what Camel can offer. But if you run, so the question is, if you run Camel or any light work on WebSphere application server, I guess it might be, you can have an embedded Mule ESB. So it would expose a servlet, so that would be the entry point for your ESB. So it's possible to embed Mule ESB into another JVM. If you want to construct your lightweight solutions using different components, like from Spring, from Camel, and from other services, I guess if you're up to snuff to this job, so I guess that would be a good way, because you can leverage your skills and you can really pick and choose the components that you want to, rather than getting the whole thing embedded. But it depends on the use cases that you have. Any more questions?